The journey of a samosa inside a modern factory begins long before its iconic triangular shape takes form. It starts with raw ingredients arriving at the facility in massive quantities, each one playing a critical role in defining the final taste, texture, and aroma of the samosa. At first glance, these ingredients may look simple: potatoes, flour, onions, peas, spices, but in large-scale production, even the smallest variation can affect thousands of pieces. That is why the process begins with strict quality control, ensuring that every single batch meets precise standards. Large trucks unload sacks of refined wheat flour, often weighing hundreds of kilograms each. This flour is carefully tested for moisture content, color, fineness, and gluten strength. Too much moisture can lead to soggy dough, while weak gluten can cause the samosa shell to crack during frying. Only flour that passes all tests is approved and transferred to sealed storage silos, protected from humidity and contamination. Nearby, fresh potatoes arrive in bulk crates. These potatoes are the backbone of the samosa filling, so their quality is crucial. Factory inspectors check for size consistency, ripeness, and signs of damage or decay. Potatoes that are too old may taste dull, while overly fresh ones can contain excess moisture. Once approved, the potatoes move directly into the washing section, beginning their transformation from raw produce to smooth, flavorful filling. In the washing area, the potatoes enter large rotating drums equipped with high-pressure water jets. These machines remove soil, sand, and surface impurities without damaging the potato flesh. The water used here is filtered and recycled, maintaining hygiene while reducing waste. As the drums rotate, the potatoes tumble gently, emerging clean and ready for cooking. The clean potatoes are then conveyed into industrial steam cookers. Unlike traditional boiling, steam cooking allows the potatoes to cook evenly while retaining their natural starch structure. Inside massive sealed chambers, controlled steam surrounds the potatoes at precise temperatures. Sensors constantly monitor heat and pressure, ensuring that each potato reaches the ideal softness without becoming waterlogged. This step is essential because the texture of the potato directly affects the consistency of the filling. Once cooking is complete, the potatoes are quickly transferred to automated peeling machines. These machines remove the skins efficiently using abrasion or steam pressure, minimizing waste while maintaining smooth surfaces. The peeled potatoes are inspected again as they move along conveyors, with any irregular pieces removed automatically. Next comes the mashing stage, where the potatoes are transformed into the base of the samosa filling. In large stainless steel mixing units, powerful paddles crush the potatoes into a uniform mash. Unlike instant puree, this mash retains slight texture, giving the final filling a satisfying bite. The machines operate at controlled speeds to prevent overprocessing, which could turn the filling gummy. While potatoes are being prepared, other vegetables undergo their own precise processing. Onions are fed into high-speed slicers that dice them into perfectly even pieces. Uniform size is critical because uneven onions cook at different rates, which can lead to inconsistent flavor. Green peas are cleaned and lightly blanched, a process that preserves their bright color and natural sweetness while stopping enzymatic reactions that could dull their taste. Ginger and garlic are handled with particular care. These aromatics are peeled, washed, and finely minced using specialized grinders. Their oils are potent, and precise measurements ensure they enhance the filling without overpowering it. Green chilies are chopped to exact sizes, allowing the factory to control heat levels consistently across thousands of samosas. One of the most defining stages in the entire process is spice preparation. Spices are the soul of a samosa, and in a modern factory, they are treated with the same precision as any mechanical component. Whole and ground spices, such as cumin, coriander, turmeric, red chili powder, and garam masala, are weighed using digital scales accurate to fractions of a gram. This ensures every batch tastes identical, whether it is produced today or 6 months later. Before mixing, many spices are lightly roasted in industrial pans. This step awakens their essential oils, intensifying aroma and depth of flavor. As the spices heat, the air inside the factory fills with a rich, warm fragrance that signals the heart of samosa production. Automated stirrers prevent burning, while temperature sensors ensure optimal roasting conditions. Once all components are ready, they converge inside large automated cooking vessels. Mashed potatoes, diced vegetables, aromatics, and spices are added in a carefully controlled sequence. These vessels are equipped with rotating paddles that gently but thoroughly mix the ingredients while applying heat evenly from all sides. This ensures that spices coat every particle of potato and vegetable, creating a balanced and uniform filling. The cooking process is monitored continuously. Moisture levels are adjusted to prevent dryness or sogginess, and the mixture is stirred at variable speeds to maintain structure. This stage not only blends flavors, but also eliminates any remaining rawness in the spices, creating a fully cooked, ready-to-use filling. Once cooking is complete, the filling cannot be used immediately. Hot filling could weaken the dough or cause steam buildup during folding and frying. To solve this, the filling is transferred to rapid cooling systems. Spread evenly across trays or conveyors, it passes through cooling tunnels where chilled air flows over it at controlled speeds. This brings the temperature down quickly while preserving texture and flavor. Throughout this entire process, hygiene and food safety are paramount. The factory environment is maintained under strict sanitary conditions. Workers wear protective clothing, machines are cleaned regularly, and surfaces are made of food-grade stainless steel. Sensors and checkpoints ensure that contamination risks are minimized at every stage. By the time the filling is ready, it represents the result of dozens of synchronized steps, each designed to achieve one goal: consistency. Every spoonful of filling must taste the same, feel the same, and behave the same during folding and frying. This is what allows a factory to produce thousands of samosas per hour without sacrificing the traditional flavor people expect. What appears to be a simple potato filling is, in reality, the product of engineering precision, culinary expertise, and years of refinement. It is the foundation upon which the entire samosa is built, setting the stage for the next phase: dough preparation, shaping, and frying, where tradition meets automation on an even larger scale. Once the samosa filling is perfectly prepared and cooled, the production line shifts into its most visually fascinating and technically complex phase. This is where modern automation takes over, transforming prepared ingredients into thousands of identical, crispy samosas every single hour. What was once a fully handcrafted process is now executed with remarkable precision, speed, and consistency, without losing the traditional identity of the samosa. The next critical step begins with dough preparation. Refined wheat flour, already tested and approved during quality checks, is transferred from storage silos into large industrial mixing machines. Here, water, salt, and a measured amount of oil are added automatically in exact proportions. These machines are designed to mimic the kneading motion of human hands, but at a much larger scale. As the mixers rotate, the flour gradually absorbs moisture, forming a cohesive dough with the ideal balance of elasticity and firmness. Sensors inside the mixers monitor dough temperature and hydration in real time. Too much heat can weaken gluten structure, while insufficient kneading can cause cracking during frying. The machines adjust speed and duration automatically, ensuring that every batch of dough meets strict specifications. Once kneading is complete, the dough is allowed to rest briefly. This resting period relaxes the gluten, making the dough easier to roll and shape without tearing. After resting, the dough moves into automated sheeting machines. These machines use a series of calibrated rollers to flatten the dough into thin, uniform sheets. Thickness control is crucial at this stage. Dough that is too thick will result in heavy, doughy samosas, while dough that is too thin may burst during frying. Laser sensors constantly measure thickness, making micro-adjustments to maintain absolute consistency across the entire sheet. The flattened dough sheets then pass into cutting stations. High-speed rotary cutters shape the dough into perfectly sized semicircular wrappers, the foundation of the samosa's iconic form. The precision here is extraordinary. Every wrapper is identical in size and weight, ensuring that filling ratios remain consistent later in the process. Any excess dough is collected and recycled back into the system, minimizing waste. With wrappers prepared, the production line moves into the filling and forming zone, where automation truly shines. Conveyor belts carry the wrappers forward in perfect alignment. Above them, automated dispensers release precise portions of the cooled filling onto each wrapper. These dispensers are calibrated down to the gram, ensuring that every samosa contains exactly the same amount of filling. This uniformity is essential not only for taste, but also for even cooking. Immediately after filling, the wrappers enter the folding section. Here, robotic arms perform one of the most delicate tasks in samosa production. Using programmed movements refined through years of testing, these arms lift, fold, and seal the wrappers into the classic triangular shape. The edges are pressed firmly together, often using a light water or flour paste to ensure a tight seal. This folding process happens at astonishing speed. Hundreds of samosas are shaped every minute, each one nearly identical to the next. Despite the speed, precision remains uncompromised. Poorly sealed samosas could open during frying, causing filling to leak into the oil, so this stage is monitored closely by both machines and human supervisors. Once formed, the samosas move through an automated inspection system. High-resolution cameras scan each piece from multiple angles, checking for defects such as improper folding, uneven filling distribution, or damaged edges. Any samosa that fails to meet visual standards is automatically diverted from the main line. This ensures that only perfectly formed samosas continue toward frying. The approved samosas now approach the most dramatic and satisfying stage of production, deep frying. Industrial fryers used in modern factories are massive, capable of holding hundreds of liters of oil at a precisely controlled temperature. Maintaining this temperature is critical. Oil that is too hot will burn the outer shell before the inside cooks, while oil that is too cool will cause the samosas to absorb excess oil and become greasy. The samosas enter the fryer gradually, often on mesh conveyors that lower them gently into the hot oil. As soon as they submerge, moisture inside the dough begins to evaporate, creating steam that puffs the outer layers slightly. This process forms the flaky, crispy texture that defines a perfect samosa. As the samosas move through the fryer, they slowly rotate or flip to ensure even browning on all sides. Sensors track oil temperature, frying time, and movement speed continuously. The transformation is visible almost immediately. Pale dough turns golden, then deepens into a rich, appetizing brown. The aroma released during this stage fills the factory, signaling that the samosas are nearing completion. After frying, the samosas emerge from the oil and pass onto vibrating conveyors. These conveyors shake gently, allowing excess oil to drip away. Additional air blowers may be used to remove surface oil, resulting in a crisp, light texture rather than an oily finish. This step plays a key role in both taste and shelf life. At this point, the production line may split depending on the final destination of the samosas. Some samosas are fully cooked and prepared for immediate consumption or chilled distribution. Others are partially fried and destined for freezing. These partially fried samosas enter blast freezers, where temperatures drop rapidly. Rapid freezing prevents the formation of large ice crystals, preserving texture and flavor for when the samosas are reheated later by consumers or food vendors. Packaging is the next major phase. In the packaging hall, automation continues to dominate. Samosas are counted automatically and placed into trays, bags, or boxes depending on market requirements. Packaging machines seal the products under controlled conditions, sometimes using modified atmosphere packaging to extend shelf life by reducing oxygen levels inside the pack. Each package is labeled with vital information, including production date, batch number, and storage instructions. This traceability allows manufacturers to track products through the supply chain and respond quickly if any quality issues arise. Quality control does not end with packaging. Random samples from each batch are sent to a dedicated quality control laboratory. Here, technicians examine texture, color, moisture content, and oil absorption. Taste tests are conducted to ensure flavor consistency, while microbiological tests confirm food safety. Only batches that meet all quality standards are approved for distribution. Finally, finished samosas are transferred to storage facilities. Refrigerated or frozen warehouses store the products under carefully controlled conditions until they are ready to be shipped. Forklifts move pallets efficiently, loading them onto delivery trucks bound for supermarkets, restaurants, street vendors, and export destinations. This entire automated process allows factories to produce tens of thousands and sometimes millions of samosas every day. Yet despite the scale and speed, the goal remains the same as it was generations ago: delivering a samosa that is crispy on the outside, flavorful on the inside, and satisfying with every bite. What makes this achievement remarkable is not just the technology involved, but how seamlessly it preserves tradition. Automation does not replace the essence of the samosa. It protects it. By controlling every variable, from dough thickness to frying temperature, Modern factories ensure that each samosa delivers the same experience, no matter where or when it is eaten. From folding and frying to inspection and packaging, this stage of production represents the perfect balance between heritage and innovation. It is the reason a snack born in small kitchens can now be enjoyed worldwide, produced at scale without losing its soul.